is, do you remember the vertex is that point on the V? And so the vertex starts, of course, at 0, 0. We use that for all our transformations. So your parent function has a vertex at 0, 0. And it has something called a line of symmetry. So the line of symmetry is going to be that line that you could flip your V over. So if I had a V shape and I flip it across a line of symmetry, it would still look like a V shape. And so that line of symmetry is right here in the middle. Since it's a vertical line, it's x equals, and then it's 0 in this case. All right, any questions about that point, the vertex, and your line of symmetry? So when we transform this graph, your vertex will be moving left, right, up, down, and your line of symmetry, of course, will move with the vertex. Wherever the vertex moves, that's where your line of symmetry will be. Okay, to write the equation of this graph, there are some parts of this equation we already know. For example, actually, let's work backwards from our transformations here. Here's where my vertex used to be, and here's where it is now. Did the vertex move left or right? Right, so you're right that it's left. It started here, and it shifted to the left 3, right? So shift left 3. Notice I'm skipping over something to come back. Oops. Shift left 3. And then, remember, it started here. It shifted left 3. Did it go up or down? Yeah, it shifted down 2. Something else happened. See how it's like, it's a little bit taller and skinnier than the parent function at the top? What was that called that makes it taller? Mm-hmm. Yeah, I heard it. 2 good answers. Vertical stretch. So it's a vertical stretch. Is there any way for you to find out, without graphing in Desmos, how much the vertical stretch is? Does anybody have a guess what it might be? So we said that it's related to this slope. Remember that? So if I'm going from this point to this point, I would be going up how many? 6, you're right. It is 6. Because it's from -2 to 4. So that's 6. And then over how many? 3. So that would be a slope of 6 over 3, which is what? 2. Yeah. So with absolute value equations, you can determine the stretch by counting the slope. But that doesn't work for all equations. So we're kind of lucky with this one that works. So some of you might be able to use that information to write the equation, but I need to teach you the other way too. So here's the other way. Taking your general equation, which is right here, we wrote that on the first page of our notes last class. We're going to substitute some numbers in. Your vertex is your h and your k. So in this case, this is h and this is k. Any other point on the entire V can be your xy. You pick one point and you pick the x and y from the same point and it will work. But they gave us this point right here, so we're going to use this one. X and y. And now I'm going to substitute those numbers into the general form of the equation to find the a value. So we're going to try to find a now. Okay, so identified on the graph what is h and k and x and y, so you can substitute those numbers in. So for the y, I'm going to put 4. the A is what I'm trying to find, and so the A will stay a variable. Okay, I can see that X is 0 and H is -3. K is -2. All right, take a minute to see how much of that you know how to simplify on your own. All right, so a lot of you noticed that 0 minus -3 is the same as 0 plus 3, right? So you got 3 there. Absolute value of 3 is still 3. So this here, all of this makes a 3a. So I have 4 equals 3a, and plus -2, you could write that as -2. You cannot combine the 3 and the -2 because that 3 is stuck with the a. They're stuck together. All right, so if you did combine the 3 and the -2, no harm, just erase it, and let's go back and make it a 3a minus 2. So now we have to get the a by itself. We're going to undo the -2 first with what? Plus 2, good.
Is that algebra?
It is algebra, that's why this is called algebra 2.
That was a good one.
All right, now we've got 3 times a, and how do we undo multiply by a? 3? Divide by 3. And we got a equals? 2. All right. A equals 2. That means there's going to be a 2 in front here. Looking here, does that 2 in front create the shift down 2 or the vertical stretch of 2? When you put a 2 in front and multiply by 2, does that shift it 2 or does it stretch it by 2? Yeah. It is stretch. So multiplying, Antonio, not helpful. Multiplying by 2 does stretch your whole equation by 2. All right, so when we're looking at this, we have to now write our equation. We're going to be using this same format, but we're going to put some numbers in. Y stays Y. A, we just found out, is 2. X stays X. Now, it's supposed to be minus H, and H is -3. So instead of minus -3, I could write what? Plus 3, good. And then it says plus K. Instead of plus -2, I could write minus 2. Yeah. Ask me that question again once I finish talking about this one, okay? I think so, but I'll go through the dates with you in just a sec. Okay, so we said the vertical stretch of 2 is this 2 right here. That means that the shift down 2 is this one right here, minus 2. And then the shift left 3, you should have remembered that's going to be inside the absolute value. Look for a path here. There we go. There's my shift left 3. All right, so it's good to be able to identify which part of the equation creates which transformation. It'll just make you a little bit quicker, so you don't have to always graph things in Desmos to know how it's going to transform. So we just did this part. Compare your equation with the transformations listed. Okay. This side says you try, but I am going to help you get started with the first one. So on this one, we're going to identify the vertex and a point. The vertex, remember, is that point on the V, this one right here. So write down the coordinates of that vertex and check with your neighbor, see if they get the same thing. All right. Layla, what'd you get for the vertex?
-4, -2.
Anybody else get -4, -2? No? Yes? That's right. All right, and since that's the vertex, that's my H, and that's my K. All right, look on your graph and find another point that you like. I don't like the y-intercept because I would have to estimate it, so I'm not going to pick the y-intercept. Find a point that you like. Tell your neighbor which one you pick. See if they pick the same one or a different one. All right, Joelle, Tabitha, Marcella, tell each other which one you picked, okay? All right. If you think the best one is -7, -3, if that is the point that looked good to you, raise your hand. One person picked that one, 2 people picked that one, 3 people picked that one. Nice choice. Good job. All right, if you like the point -1, -3, raise your hand if that was your favorite point. One person picked that one. Also good. It works very well. If you like the point 2, -4, raise your hand. All right, 1, 2, 3 votes for 2, -4. And if you chose 5, -5, raise your hand. Oh, lots of votes for 5, -5. Very good. I believe that those are your only choices. Oh, wait, unless you chose, anybody choose -11, -4? No, okay. So you got to choose ones that land right on the grid, okay? I am going to go for this one because I hadn't used this one before, 5, -5. But you can use whichever one you want. If you use 5, -5, then after you do the problem, you can check your steps with me, but we will all end up with the same answer no matter what. So take the point you chose, write the coordinates, and then remember that that's what you're going to use for your x, y. All right, so I want you to take a moment now, try to find your a value, and then write your equation. And then you're going to write the transformations for that. Mine ends up being a positive number anyway, that's 9. But if yours was a -3a, that negative turns positive once you put that absolute value on it. So you should have a positive number in front of your a. And now I'm going to add the 2. And I'm going to divide by 9. And I'm going to show you why Desmos is a better calculator than your phone calculator. So you can get Desmos on your phone. If you love using your phone as a calculator, just open a browser and type desmos.com. You can use Desmos on your phone. There's an app, but if you don't want an app, just use it on the internet. So -3 divided by 9, okay? So a lot of you guys ended up with this number, -0.33333333. And then some of you knew what fraction it was, but if you didn't, Desmos lets you just click over here and make it to the simplified fraction, -1/3. Okay? So your a value, no matter what numbers you picked, you should get a as -1/3. You can't do what? So the decimal was not as good of an answer because you had to round it. The fraction was the best answer in this case. So now writing my equation, I've got y equals -1/3 x. Here's my h. So instead of writing -4, I write minus negative is the same as what, guys? +4, thank you. And let's see, and then instead of plus -2, I'm going to put -2. All right, we're going to name the transformations. You can challenge yourself. You can challenge yourself to name the transformations just from the equation. So looking at the equation, I know that +4 is going to move my graph left 4. Or you can look at the graph to name the transformation. So remember, it started here and it moved here. Okay, so moving from here to here, it shifted left how many?
4.
Left 4. And then down how many? 2, good. What is it called that flips it upside down? Reflection.
Stretch.
All right.
Stretch.
So we're going to get to the stretch versus compression in just a second, but let's first write the vertical reflection. That just comes from the negative sign, vertical reflection. And before you tell me if it's a stretch or compression, I'm going to remind you what they look like. All right. So you've got your V shape, okay? If it is stretched, somebody is pulling it from the top. They're pulling it and making it taller. If it is compressed, somebody is pushing it down, and that makes it wider. Is ours stretched, or is ours compressed? Compressed, yeah. So this is compressed, and the number it's compressed by is this number here. I prefer that you say it's compressed by 1/3 because we already used the negative for the reflection. But if you said it's compressed by negative 1/3, I wouldn't complain too loud. Compressed by 1/3. Okay. All right, there's another one for you to try. Okay, here's my vertex at 1, 2. That's my HK. And here's, actually, most of you guys use this point right here, right? You use this one, which is 0, 5 for your X, Y. You could have used a different point, but I saw a lot of you use that one. So I'm going to substitute in for my Y and my X, my H, and my K. What is the absolute value of negative 1? 1, yeah. Guys, the absolute value function is the distance a number is from 0, and it's always positive. So absolute value of negative 1 is 1, absolute value of positive 1 is 1. True. Yes. So I get 5 equals positive 1a plus 2. Folks, I'm hearing a lot of chatting, but a lot of you guys need to fix your work. Okay, for your A, you should get a positive 3. Just by looking at the graph, I know that A is positive. How? Looking at the graph, I can tell that my A is positive because it doesn't have what transformation? The reflection, which comes from the negative. So if you were upside down V, you would have a negative A. If you're right side up V, you have a positive A. So if you get a negative A, but you're not reflected, you know to go back and check that. So now that I have my A is 3, I can write my equation Y equals 3, absolute value X, then minus H, and then plus K. All right, before you switch over to the new homework assignment, let's talk about the last homework assignment. I think I'm out of them, but I will pull it up here for you.